Okay, good morning everyone and welcome here to the Big Tech Day 2026. I'm super happy to have such a huge crowd here in this room and also some people that are visiting us online in our Zoom stream. My name is André Schneider, I'm the host for the first talk today. Let's get started with our first speakers for today, which are Mathias Burger and Áron Erdelyi with their talk on MCP and the emerging agent protocol stack. Mathias is a principal consultant at TNG. He primarily works on AI projects. He has a focus on computer vision and natural language processing, and he has been working on AI topics for customers since already almost 10 years now. He is a true expert, which can be seen in his preference for studying the latest scientific findings and his motivation to share the insights with others in the project and beyond. Enabling others in AI matter brings me to our second speaker, which is Áron. He's a senior consultant at TNG. He focuses on integrating modern AI capabilities into scalable cloud-native architectures. He works on generative AI applications and practical AI tooling for developers. This enables him to help others adopting AI responsibility while keeping engineering quality, performance, and maintainability front and center. And with that, stage is yours.
Thank you for the introduction, and hello everyone. Welcome to this talk, MCP and the Emerging Agent Protocol Stack, a field guide to MCP A2A, generative UI, and related standards. We have a lot to get through today, but let's start with a quick show of hands. Who has ever set up a connection with their coding agents? Let's see. Okay, I think that's basically everyone here. Next one, who has ever built an MCP server? Now, it doesn't have to be production grade. Who has ever played around with it? Yeah, a little less. Now, a little curveball here. Put your hands up if you know what elicitation is. Okay, yeah. Yeah, the thing is that most people don't really know what MCP is, let alone all the other stuff that we'll talk about today. And people, they don't know how this works, what it enables, the risks that come with it. So still, everyone in this room and probably everyone at the conference is already depending on it. So if agents are going to perform actions in the world, they need a common way to discover capabilities, execute tools, ask for context, request for user input, and call tools safely. So, I'm Áron, and this is my boss, Mathias, or at least the closest one can get at TNG to a boss. We work at TNG, and we've been building MCP servers and the stuff that we're going to talk about today, used by enterprises for some time now. And in this talk, we'll follow the path from the time before MCP to the old integration mess, through some technical details and case studies, and then we'll talk about rules of thumb and how these protocols relate and when to use what. So, most everyone's using MCP. You've all put your hands up when I asked who has ever set up a connection with their MCP server, but do you actually know what it specifies or the problem that it solves? So let's talk about the time before MCP. Early LLMs could reason over text. You pass in a half-finished sentence, and it guesses the most probable next word with some randomness or temperature. You could paste in text, it would spit out natural language, but mostly that's it. You could even use it through probably an API, but it was still, I would say, toothless. So then, basically, every provider and framework started coming up with ways that their model or framework would use to start interacting with the world. Now, the problem is that every model, every app, every tool, every database, maybe even every local file system needed custom glue. And, the frameworks and libraries like LangChain, they started coming up with tool calling abstractions, giving developers or early adopters these kinds of abstractions that they could work with. But each tool plus model and host combination would need bespoke wiring. You can imagine how even small changes or shame adrift or even brittle prompts would then emerge as more maintenance cost for the developers. And the MCP pitch starts here. You turn many explicit integrations into higher order or higher level and less complex abstractions that you can share across your ecosystem. MCP, which by the way stands for Model Context Protocol, promises a common way for agents and applications to connect to, discover, and use tools, data, prompts, or even user workflows. So less custom glue and more reusable functional code. The funny thing is that this didn't even come from an executive decision, right? This came from an internal pain of the engineers. They invented it themselves, and this is how it all started. Well, your host app contains the MCP clients. The host app can be anything from an IDE like Cursor or a customer service chatbot, basically anything that handles orchestration. The MCP servers, which you can see on the right, expose these capabilities, for example, tools and resources. The important mental model is that servers do not have to know every possible host, and the hosts do not have to custom code every possible tool. Any MCP-compatible server can expose tools and resources in a unified way, and every MCP-compatible client can then consume these exposed resources. There are two channels that the client and server can communicate through. The first one is standard input-output, and this is common for local MCP servers because it is simple and easy to launch as child processes, and it also fits the local coding agent or local file system aware tool shape pretty well. It is also much safer because both the invocation and the processing of the call will stay on the user's machine. The other channel is streamable HTTP, which is an evolution on top of HTTP plus SSE. It supports long-lived connections, asynchronous messaging, notifications, and even streaming responses. Now, remote MCP really changes the whole security model because the server is not just a local process on the user's machine anymore. This is where auth, consent, enterprise gateways, and stuff like this become more important. So let's get to the point. What does MCP actually enable? What does it define? I'll first talk about primitives that you already probably know, then some more advanced ones, and then we'll see an actual case study of how this all threads together pretty well. The first one is one we all know and love. It is tools. This is an actual excerpt from a coding agent running on the machine that I'm presenting from. But I'm sure that every one of you has already seen examples like this. They are callable actions with names like, for example, patch or shell. They also have descriptions and a lot of more info and metadata in their input schemas. This schema really helps the client and the model understand what capabilities or what arguments the tools actually need or what they can do. They can wrap external APIs or external systems, database queries, file operations, basically any side-effecting operation. Prompts, which are the second primitives I'm going to talk about today, they are reusable templates of workflows exposed by the servers. Their point is to encode known ways on how to start a task, or and not forcing the users basically to perfectly remember on how to start a user workflow every time. You can think of / commands in Cursor, and they can be built-in prompts which are static or even dynamic prompts. The point of it is that the user is explicitly calling this prompt, so they don't have to remember on how to start a workflow. The third one is resources. They are readable contexts that are exposed by the servers. They help agents inspect relevant state without basically turning everything into a tool call or an action. You've definitely seen some of the examples coming up here. In your agentic IDE, you've definitely seen this file referencing mechanism. In Cursor, I believe you put an @ before referencing a file. Well, this is the basic idea, but here's another one. For example, when passing a file in Claude Code, you're obviously not passing the file directly to the model as a binary. I mean, first of all, it would be useless because what's the model going to do with a binary? And secondly, it's going to take a bunch of context. So it will be exposed as a resource to the model that the model in turn can access when it needs to. And what's also great about this, that it gives the server time to actually process the file. So if you imagine there's a PDF that you want to pass to your model, just passing the PDF is not going to work. You need some processing for the model, for it to actually make sense to the model. So The server has time to process it and expose it as a resource to the model. So how does this work? I mean, I've brought some code examples here, just so you can see that the resources are uniquely identified by a URI. And this is pretty important. They can be static, or in the next example, they can be dynamic, which is really great. I mean, these are pretty simple examples, but you get the gist. And I'm not saying that from now on you should only do resources for any non-side affecting tool call. I'm just saying that you now have the chance to manage context in a very structured way so that it makes sense to you, the agent, and if it doesn't make sense for a resource to be uniquely identified by URI, I say you use tools. All right, now we're going to move to some lesser-known primitives. The ones that we've previously talked about, the last three, they're server-side primitives. They're functionality that the server exposes. But the client can also expose some functionality towards the server. So let's start with the classic. We have sampling. This is when the MCP server requests LLM completion from the client. And it enables the server to delegate AI reasoning effort to the client without the server having access to or having credentials to a model. This means that the client will have full control over how it processes the sampling request. Not only the model choice or for example, how much you want to log, but also you have direct access to what messages you want to send to the model that is being sampled before returning it. Next one's routes. These are areas that the server is allowed to, or at least expected to, operate within. They help communicate scope, but they're not a complete security boundary just by themselves. You can think of like projects on ChatGPT. You have a project, and in a session it generates an artifact for you, and that artifact is going to be available to other sessions within the same project. Well, this is the idea. Routes inform the servers about the resources that the client is able to provide. And the servers can then adjust their behavior to provide more relevant responses. And yeah, you can imagine why this could be very, very useful. In the previous Claude Code example, for example, if we have a file reading MCP server that would get the information that it can expose the processed files in that specific project as a resource primitive to the client, yeah, it's getting complicated. But again, you also have full control over this on the client side. You can decide on how you want to do this, but be warned that the servers are not bound by the routes. It is something that they can request, but they do not have to respect it. And finally, we arrive to elicitation, the big question at the beginning. Elicitation enables interactive workflows through requesting user input during a workflow execution. For example, which branch or which file, which environment, or which customer record if it hasn't been specified by the tool. The server can pause the execution of a tool and then query the user for missing information. But there's another very useful feature that elicitation can be used for. It can also direct users to external URLs for sensitive user interactions that must not pass through the MCP. For example, a third-party authorization on behalf of the user. I mean, you can imagine why you don't want that passing through your MCP, right? So we've learned about 6 primitives here, but let's all thread it into one big example. And imagine I ask an agent to prepare a release note for a new version. Sounds simple enough, but it needs context, it needs scope, it needs planning, maybe some user input, and finally an action. First, the client will tell the server what's in scope. In this example, the root is the product API repository. That doesn't magically sandbox the server, but it is a clear boundary for the task. It shouldn't go searching in any other repository. Now, once we know what repository we're working within, the server can expose readable context as resources that might be relevant to the actual workflow. Still, nothing has happened yet, but now we have all the useful information exposed to the client, like the changelog, issues, latest merged PRs. Now we have the tool call. This is the side effecting step. The agent has scoped the repository, read the context, and now it wants to create the draft release. We have the raw material, but we still need some language work. We need some nodes for the release. And with sampling, the server can ask the client to actually run the model. It doesn't need its own credentials. We can request for reasoning effort on behalf of the client. And lastly, the server may still be missing a decision. It could guess, but you don't really want it to guess, right? Elicitation lets it pause and ask the user through the client. And in this case, the user can decide whether they want, or what belongs in the release notes, whether it should be a final or a draft, or should it include internal refactors. So this is the whole flow. Root gives it scope, resources provide context, tools perform the action, sampling does model work, and elicitation asks for human input. Let's move on here. There's a lot to get through today and talk about auth. Now, auth in MCP is still pretty bad. Nothing is required by MCP, but let's talk about it. It's practically two worlds. If the server one runs locally, like a child process of your coding agent, then you usually bring the credentials from your own environment. Like GitHub token, AWS profile, you can imagine, that's already on your machine. It's simple, and it's what developers need really for a simple setup like this. The moment the MCP server is remote, however, it's not just read my environment variable anymore. You now have a real trust boundary, users, tenants, consent, and so on. This is where OAuth enters the picture. And this is the important bit. Remote MCP should not mean take whatever token the client has and forward it everywhere. The MCP server is a resource server, meaning that the token is meant for that MCP server. If an unauthorized client is accessing an MCP server, it can respond with a protected resource metadata, and then you have the OAuth flow. The server that needs to talk to GitHub or Jira or whatever, it needs a separate upstream token, so it does need an exchange or at least an on-behalf authorization. And you really don't want your tokens to be passed through this. So this is some stuff that developers need to watch out for, because MCP allows for really bad designs as well as some good ones. So pay attention when you're handling this. The second question is not only how does the user log in, it is who is the client and who should be allowed to access. And in an enterprise, the clean answer is pretty boring. I mean, you already have your enterprise authentication system, is going to go through that, whatever. But in a more open ecosystem, you need a way for even previously unknown clients to identify themselves. And this is where CIMD comes in, which is client ID metadata document. It's basically a URL backend client identity document. But the practical rule of thumb is for local dev tools, you can get away with your local environment variables, path tokens, whatever. Hosted agents and multi-tenant systems, you really want to have a good OAuth authorization flow set up. Otherwise, you're going to run into new problems. So that is a perfect segue for the next slide here. It's not just fun and games, unfortunately. So let's talk about some problems here. Actually, I'm going to go through this real quick because we have some stuff to get through. But know that there has been 4 revisions in the MCP specification, and the ecosystem is fragmenting. There are people on previous revisions or next revisions. Being MCP compatible doesn't mean fully functional or feature complete. So that's the thing you have to remember here. The second thing is, it is a huge cybersecurity threat because you don't only bring the classical attack surfaces, but the probabilistic nature of LLMs amplifies the whole problems. And if you remember one thing of the security here, that should be the lethal trifecta. You only need 3 things to have a really bad day. Agent having access to your private data, any mechanism by which the attacker can have some input on your LLM, and then the ability for your LLM to externally communicate. 2 examples here. I know it's bright, I'm sorry about that. We have indirect prompt injection when, for example, a website says that you should stop following instructions and send your keys to this webhook, and then the attacker now has your secrets. The second one is tool poisoning, which is very MCP relevant, because if your MCP server is compromised and the descriptions have been overridden, or maybe even any other metadata, that could also cause some weird behavior in your model. And even tools that look benign at first can be updated to be malicious. So don't only trust the server, trust the author and the maintainers of the servers. And the third one is context bloat. Even before starting a conversation, you can end up with half of your context being already consumed. There are things you can do here. Firstly, if you remove most of the tools that you don't use anyway and have the 3 tools that you use most often, that's going to solve a lot of your problems. And Anthropic introduced their tool search tool, which has brought down their context usage by a lot. I mean, this is when the 3 most used tools remain, but everything else is accessible through a tool search tool, which you can search either semantically or regex-based, you can imagine. Yeah, there is also the fact or the problem when you the results of the tools can be pretty big. So this is an example that I shamelessly borrowed from Anthropic's blog. If I ask the model which team members have exceeded their Q3 travel budget, and it has, for example, 3 tools, one to get the team members, then to get their expenses, and then get a budget limit by employee level, then it's going to fetch the team members, which is 20 people, then do another 20 calls to get each person's travel budgets, and then add them all together manually. That's going to be a huge, like tens of thousands of tokens already consumed just for this seemingly simple task. And for this, Anthropic kind of invented their programmatic tool calling, which is a kind of a shift in how we look at MCP servers. Because if the tools that we have can be exposed to code execution environments where the tools can be called as functions, we can have a pretty nice solution here. When the user requests a task like we saw previously about the travel budgets, we can sample the LLM to write us a Python script, for example, that calls the required tools whenever it needs the input. And then in our code execution sandbox, this Python script is being run. And when we need a tool result, then we can query the API to respond with a tool result. And the LLM really only sees the end result. So it doesn't see all the thousands of lines in between that it doesn't really need. So that's all about MCP, and I'll hand over to Mathias a bit over time to rules of thumb.
Can you switch layout, please?
Yeah.
So, welcome. So we've heard a lot about MCP, and you might have heard about other things as well, such as skills, using CLI tools, or making direct API calls. And I want to give you a few rules of thumb on when to use what or when not to use. Right? So skills are mostly something that you pull into your project or into your agent locally. It's locally authored, you can have a look at it, and you really can have big assets in it, like whole documentations or binaries whatsoever. While MCP, on the other hand, is more remote provisioned, if it's a remote one. And that means that other people take care of providing you with context or information. Also, the MCP server allows to hide information behind authentication, for instance, which is important when you want to follow the need-to-know principle. Also, MCP can expose via the resources and via tools instructions to the agent, which can be dangerous also when it is instructed to do malicious stuff. But so you can also give the agent some hints if you need to do. Well, so basically, when you want to connect to a live system, you use MCP. And when you want to know how to do things, teach your agent how to do things, then you can use skills. About CLI tools, a little word of warning. So whenever you logged into AWS or the GitHub command line, for instance, here the authentication is ambient, it has already happened. The AI could just call the shell commands and wreak havoc, right? So you will have a really bad day. But on the other hand, it's very powerful because you can construct like shell pipes, and every intermediate result does not enter the model context, but only the final result coming out of your pipes will enter the model, which makes it powerful. So for whatever is local and you need to do locally, it's very powerful to use CLI tools. But when you need more security or you're a non-technical person, it's probably much safer to use MCP. So the thing about direct API calls is that you need a few capabilities first, like code execution or shell access, like we have talked about already. And when you access APIs directly, you need to get access to credentials, so probably via credentials manager. But beware that the model shall never pull credentials out of environment files or read them out of the credentials manager itself, because then you expose it to some untrusted LLM provider, and your secret is basically leaked. Then you need to rotate it already. So that happens quite frequently, as I've seen it in customer contexts. So try to avoid this, and you can avoid this by creating scripts that use, for instance, a credentials manager, and they never expose the secrets anywhere else. Okay, so if you don't have an MCP available, you can still do direct API calls and command line, so that's a fallback option, but beware of secret leakage. So, well, having talked about that, I want to present two ideas today. One of them is getting from this mess of text that you're getting from your agent to some clearer, well-structured information, basically getting from text to visual. So what are we missing when we're confronted with tens of thousands of tokens, which we cannot all read and reason about ourselves, because otherwise the promise of getting our work done faster would not hold anymore. So mostly we need something like tables. So imagine like you want to bulk create a bunch of Jira issues as product owner. You have this Confluence page, you've got a lot of nodes taken down, but now you want to structure it. Then it would be good if your agent could create something like a table with dependencies between stuff, with names, descriptions, acceptance criteria, but also the LLM does not everything as you want it. So you might want to be able to edit it yourself, to reorder things, to input yourself. Then you could have some graphical UI widget, which does this for you. Also, to have a better understanding of architecture, for instance, or of data like charts, you need some illustrations, right? Otherwise, it's hard to reason about architecture or your data. Also, you might have seen it if you ever looked at a Git patch, plain text does not read very well, but the highlighted diff reads very well. So it's a huge point for visual information. Also, you can create workflows, interaction possibilities, maybe even preview things the AI has just generated, like documents, slide decks, or whatever. And then if you want to go, like even fully generative or fully on apps, you can do this, and they can even become full screen within your agent. So before we dive deep into this, there's a little spectrum of generativity, of effort the model has to take. So there are some components like this choice component here, where you can select from a variety of dishes for the evening. This is pretty much pre-structured. It just takes as an argument a list. The user will select something, and the model gets back what was selected. Semi-generative means the LLM has to put in a bit more effort. Charts is a good example for this, because there are libraries like Apache eCharts, and they can be very mighty. So you can have multiple data series, even stacked charts whatsoever. And there are different formats. And you don't want to expose a tool per chart format, right? So then the LLM would input just a configuration object of this chart, a description, declarative object, and it will render. And then on the other side of the spectrum, there's fully generative. So let's say you're repelled by the calories for your evening dishes and better decide to play a little platformer game instead. Then you go fully generative and have some application rendered inside your chat that never existed before and is fully contextually appropriate. But also it needs to be secured. And this is where the MCP apps infrastructure comes into place. MCP apps themselves, they render inside something that's called the host. So that's mostly your chat application, for instance. It's backed by an MCP server, so it has a backend to call already. You don't need to provision or deploy another backend. And it's sandboxed within an iframe so that it cannot access your outer chat application. So, how does it fit into the MCP tools ecosystem? It's very simple. First of all, there in the tool description, there's some metadata field pointing to a resource URI, which is a single HTML file with JavaScript and CSS bundled inline. And then the tool call is split into two parts. One part is the content that comes back from a tool call, which goes to the LLM. Think of this as a summary. And there's structured content. This can be quite bigger. That goes into the UI. The model context will never see that. OK, so what's the life cycle of this whole operation here? First of all, you discover your tools via the MCP tool listing. Then your agent decides, I need to render some kind of widget. It can already prefetch the resource, cache it, and construct the view inside your chat application, for instance. And then when the view is rendered, it says, yeah, I can be initialized. Then it gets injected some context, like the theme. Some people have light theme, some people have dark theme. This is information coming from the host, as well as capabilities, such as may I go full screen or not, and the like. And then data needs to be injected into this application. So for the tool call, the LLM already made up some parameters. This is what you have instantly available. But if you create some data within your tool, this can take longer and gets into the tool response. This is also fed into the UI then at a later stage, but many UIs just don't need that because they can live with very basic parameters already. Well, and then we get into the interactive phase where the user can click around and invoke actions like, oh yeah, I've updated my table, now I need to put this updated table back into the model's context so that the agent can continue with this updated data. Well, and in the end, yeah, you have the teardown where the view can decide to persist its view state. Let's say you have a weather widget that has a compact and a pretty mode. It could save like whatever choice you have made, for instance. OK, so where does security come from? Basically from the content security policy and from iframing. So the security policy basically allows nothing. So you don't have outbound access, and you don't have host DOM access. But you can allow certain capabilities, such as clipboard access, for instance, and you can configure connect domains where this iframe may connect to other things, like your backends you have provisioned if you need them. Because there are a few drawbacks, like you cannot sample within MCP apps, so you might need to roll your own LLM in that case. So consequences, you need one HTML file, have no access, and that's a good thing, because that's the security concept here. So drawbacks, especially having one HTML file in practice, is a bit nasty because you have to create single file outputs, which for React or Preact and Vite works quite well. It's like configuring a plugin that's called single file. With Angular builds where you get chunked outputs, you might need to reassemble. OK, so that was the first idea. Second one is going from one agent to an agentic society, modeling our corporations, our roles, and everything. So whenever people say that MCP is the USB to plug in tools, then A2A is the phone line between agents. Why do we need this? So first of all, it's a good thing to have MCP tools, to have it local, to have sub-agents in your agent runtime itself, because the communication pattern is quite clear with an orchestrator and only sub-agents. There's no endless recursion. There's no going in circles, so it prevents all of this. But sometimes you have to cross boundaries of ownership, execution, and trust. And this is where agent-to-agent comes into place. Because we've modeled our orgs already in business units, special functions, individual roles, and people know how to maintain their agents within their respective roles. And that's also kind of delegation of work, right? So the org chart works, so we want to model something similar. And so each one gets their digital twin. Like for your role in, let's say, sales or finance, you have your digital twin, you define your skills, prompts, MCP tools, whatever you need. The human still steers, reviews, approves, overrides what the AI does, because otherwise quality will drop a lot, because LLMs make mistakes. Well, and then your knowledge, execution, and trust are exactly where they need to be, and agents need to communicate with each other. So that's essentially what A2A standardizes. If everyone would do this themselves, you would end up with this integration mess again. So first thing is you need some kind of discovery. That's where agent cards come in. They tell which kind of capabilities there are. An agent will list agent cards and then know which agent to call under which circumstances. There's also messaging in tasks. Some things are synchronously, directly returned, but some tasks are long-running. Let's say you need an analysis from legal. That may take a while. So you get back a task with an ID, and you have tools for listing the task status, essentially, or can get a push notification back. Streaming is pretty obvious, and enterprise concerns such as authentication need to be resolved. Observability is not quite built in, but the observable surface, like task IDs and state, are clear by the standard. Okay, so the flow, I think we had it already. Let's talk a bit about the tasks themselves, because within those tasks, artifacts are created. And tasks have a certain state. So whenever they are submitted and picked up for working, then they may get into another state like input required. So this is where the agent suspends this task, can work on other things, and will get back to you, communicate back. And the one agent that called the other one will provide further input, and then it can resume its work, for instance. Also note that you need to manage artifacts, mostly referencing by ID, I would say, because you never want big artifacts in model contexts, right? So there are also extensions, like we had it with MCP and MCP apps. So agent cards define this extension section, and there's a pretty well-known extension called A2UI for generative UIs. This basically defines the payload. It says that as JSON, you can transmit a schema of how your application looks like. Let's say 2-column layout, one chart here, one chart there, for instance. And that's where it's also a bit more powerful, because you can really build bigger applications like dashboards, which MCP apps, which just render single widgets, could not really provide well. And it's also transport agnostic, so you don't need to run it over A2A. Basically, everything that can handle JSON works, so SSE, WebSocket, gRPC, or anything else. Okay, so the end-to-end flow in A2UI is there's the concept of a surface update and a data model update. So whenever this update is triggered, the other side receives the definition of the UI and the data to render inside of it. And then the begin rendering event fires, which tells the other process that everything's finished now, information is complete, and it can create the view. And then we have the interactive phase, a bit like with MCP apps again. So how do the two now relate, the MCP apps and the A2UI? So MCP apps are sandboxed in an iframe. That's their security concept. Security from A2UI lies in the fact that there's no executable code. It's just declarative. And whenever you need, for your UI, a deep integration into your styling and theming and accessibility, you should go for A2UI, because the host decides how to render. It has its own catalog of components it can render, and they can be in your corporate style. With MCP apps, you just have to take what the MCP server offers you. So one thing is latency. We've seen the spectrum of generativity. MCP apps is mostly on the less generative spectrum to quickly display some easy widgets. And A2UI is getting into the fully generative, because the model needs to reason about how shall the UI look like, create the whole schema compliant, and that takes a while. Nowadays, this can take up to 60 seconds, so it's really high latency, but with better chips like from Cerebras, it will get quicker anyway. Okay, so that was a lot of information, I guess. So if you shall take anything home, it's do MCP authentication properly with OAuth and token exchange, and maybe with CIMDB. A2A auth is also described as even more flexible. You can even have API keys, which MCP does not offer. Sandboxing is important wherever. So your agent, when it executes commands, it shall not destroy your local file system, it shall not access things like sensitive data. So your agent shall be sandboxed, your MCP apps have some sandboxing concept, so it's everywhere. If you want to run your things, then managed runtimes are quite good, like Agent Core. You can really quickly spawn a process that even does heavy lifting. Everything's managed, it's serverless, you don't need to take care about CPU provisioning, RAM provisioning. You can run document conversion or whatever. So that's a good thing to run your things on. And you can run A2A agents if you need to communicate across boundaries. But your default with agents should be connect them to MCP tools. Only if you have to cross boundaries, use A2A. Then still problematic is prompt injection, the tool poisoning, and the secret leakage. That's the three things we often see. So please take care to prevent them. So basically, patterns we would reach for is for shaping the agent's world, you have README MDs, yeah, not the agent MD. README MDs shall contain the important information, and agents shall behave like proper developers in the coding sense. For instance, an agent's MD should just list what the agent needs to do, but not have intertwined the information for agents and humans. It's just like steering the agent where it does not fit properly. Yeah, the skills are really growing your knowledge base, your processual knowledge, which is important. Sometimes you have to do processes like implement something, test something, verify according to the specification. Then you need to follow those processes, and they can be very well packaged into skills. Progressive disclosure is there for MCP tools and skills, so you can load them on demand. Yeah, and the MCP tools provide you the access to external systems or composite operations, as pointed out already. If you have all this data being returned, putting it into other tool calls, your context gets bloated, so provide composite operations that make sense to an agent. Yeah, and don't forget, you need a human-friendly and trusted workflow. So humans need to verify still, LLMs make mistakes. Humans need to specify and verify. For the autonomy, the sandboxing. Humans shall approve things, and they shall also be presented all the information they need for decision taking. So with Claude, I often notice that it asks something, but it did not present me with a proper report I can take serious decisions on, right? Yeah, so that's basically it. Open problems was a trust. Human in the loop is not resolved at every company yet. And data poisoning is real.
That's it. If you guys have any questions, please feel free. We literally have 30 slides of appendixes. Yeah, good away.
Thank you so much for this interesting talk. Questions, please.
Thank you. Very interesting. I have a question more in the meta area beyond the technology. Like, do you have any advice how you would manage like the massive amount that's been growing around skills in a company, agents that are being built in different places? You mentioned the idea of an org chart and to mimic your organization with agents, but who maintains those and who tells them what to do? Because it's a lot of business decisions to be made there, and it's not just a technical problem. And I'm just wondering, did you see in practice a central registry or catalog of skills and agents and things like that, and something that really works well today?
In fact, we do see that, but what we see is that there are marketplaces as GitHub repositories. You cannot enforce any need-to-know principle, nothing. So that's where we identified some gap and tried to run our own agent skills management library, which you can see downstairs also. We also believe that when you pull from whichever GitHub repository and something gets poisoned, things turn out ugly, very pretty. So our idea would be introducing some kind of proxy, which also can do things like compliance checking, because no one shall get the idea to process CVs using AI. That's forbidden by the AI Act. It's high risk, at least. So I think that there's a real gap. And I think managing the knowledge, finding near duplicates and things is important. Also maintaining quality, because if your skills are not single responsibility and mix many things, then you will get a variety of different skills and pretty much big of a chaos, and it's not maintainable anymore. So deduplication is a thing. So you might want some AI approval, AI review for conciseness and the duplicate checking, but that you have to build on your own. And it's like knowledge management, like your Confluence. It can get pretty nasty if everyone documents and no one structures. So that's why you need to put serious work into, I guess.
Thank you so much for the very interesting talk. So let's say we have some chat interface where you have basically like Markdown in, Markdown out, and we want to now have like generative UI interfaces in this. Do we need to go like all the way like via MCP, agent to agent, agent to UI, and so on, or like is there a quicker way that we can like have generative things in the output?
There might be a quicker way, but you need to have some protocol. So talking to your UI you need to define payloads in response, like you get back plain text or you get back an image or whatsoever. So if you do this, if you have your own wire protocol or started doing it already, then you can integrate your own declarative style of returning widgets or things like that. And if you have the chat application under your control, you can just send a tag around with parameters, and the UI can react on this. That's pretty much possible. But that's exactly the thing. Everyone builds their own, and there's a real integration mess. We also build our own, so we're sitting on our tech stack and need to maintain it. And these ecosystems these days are pretty brittle. The changes, specs change a lot. But the idea would be that one day it would be properly standardized, hopefully, and reduce our tech stack again to reduce maintenance costs.
I was wondering, how do you guys audit and monitor the MCP servers that your developers are using?
I don't think there's a way. If you're not whitelisting all of the connections, you're not going to get a way to measure everything. Or if you're not auditing the actual, MCP.json in the VS Code of every developer, or not whitelisting every connection that they have, you're not going to have a way to enforce it. I would say, firstly, having a good education of that there is a lot of dangers out there is helpful, because when I started using these technologies, I would use some skills or some MCP servers without actually looking at the schemas of it or looking at the functional code. And if you have education telling you that, this is freaking dangerous and you'll leak the company's secrets, that's a quick way to do it. But I mean, if you have your own MCP registries, your own, if you own the server, right? I mean, that's going to be a really nice addition, because then you definitely know that you're going to be safe. If you're using an MCP server quite frequently, I'd even say that you fork it, and that's what the developers can use, and then you have full control over the server itself. I don't know if you have something to add.
Yes, so many companies are building restrictive ecosystems with proxies where people cannot just make HTTP connections or something anywhere. So they would whitelist MCP servers, maybe run on a subdomain or whatever, following some pattern, only internal servers, and just not use the external ones. Because with the external providers, you never know. It's out of your organization's control. So that's where you source them in. If they are open source, that's really great. You can run them on your own. And many applications like your Jira, that's cloud these days, okay, with MCP. So data is leaking somewhere, and they could read it. And they can read your content anyway, because you have your data there. But GitHub Enterprise, same thing. You're moving to github.com, right? They need to pay a bit attention what goes in and out. You could have some kind of proxy that does best effort on like secrets leakage or sensitive data, but it's a statistical process. You cannot do more than best effort.
Thanks for the talk. I would be curious, where do you see this MCP to UI or agent to UI frameworks in production? Because I think they're super helpful for playing around, making an impressive demo. But what we've seen since basically 2 years is when in production you rather have, I have a JSON output and now defined UI. Did you actually experience a lot of good use cases of generative UI in production environments, in enterprise use cases, etc.?
No, I did not see them yet, but MCP apps are a bit more stable, and they are started to be supported in agents like Goose, Claude. Claude is a bit difficult. You need to get it into the marketplace. You cannot just declare your own MCP app server. That's impossible. But GitHub Copilot in VS Code, for instance, can do MCP apps, and we've started to run our own, because sometimes we really want to display some charts, or whenever you want to create a simple QR code, don't want to install anything, you just want to use it. So we just called it UI basics and did some very generic Apache eCharts component with a bit of TNG styling, hints for the configuration.
But even if you're not talking about MCP apps, but just like some pre-structured stuff, you've definitely already seen like, just think about when your agent asks a question and gives you options that you can choose. That's a pre-structured something. It's not for MCP apps per se, but it's the same idea.
For me as a developer, it's amazing. I'm
Yeah.
just wondering what platform.
I would say it's a glimpse into the future. It's becoming more mature, more stable, and I think we need to get back from terminal and text walls to structured content. So what we're doing these days is we generate HTML on the fly or something, then open it in a separate browser, and the UX is quite bad. Yeah, you have to switch tabs all the time.
Okay, then thank you all for this very nice discussion afterwards. I want to advertise Aaron's second talk today.
Oh, yeah.
It's about Break Me If You Can, evaluating safety robustness in AI models. It's right after the lunch break in the Kleine Lokhalle. And with that, thanks again to our both speakers.
Thank you.
Thank you.